Hello everyone and welcome to my YouTube channel. So in this tutorial we are making a Harry Potter invisible clock using Python and Opencv. I will upload a demo video on my YouTube channel. So this is the demo video. So let's play it here. So you can see I am talking right now, and after I am writing a clock, so it will invisible. Okay. Hope you will see the movies of Harry Potter. Okay, so it is the invisible clock. So in this tutorial we are trying to make this one. So let's close it right now. I already create a file in my subindex. Is an empty Python file, clock.py. So in this tutorial we are going to use the Opencv. So that's why we have to create the first initial frame of the Opencv for video capture frame. So import cv2. So let's zoom it a little bit. Then we have to create a video capture object, so which can help us to capture the video from our initial camera. So it's called the video capture, is a class. So we have to create the object of the video capture. So initially put here 0 because of we are using our default webcam. Then we put here while true rate, and let's say image, and video dot rate. So we are reading this video capture frame using this video dot read method. Then we have to put here a Mishu method, so which can help us to create the initial frame. So into name, let's say display, and the mat, let's say the material, this should be image. Okay, and you have to put here a white key, so it will illustrate our frame. So white key, let's say 1. So let's put into a variable k equal cv2 dot white key. Then if anyone press q from the keyboard, so this infinite loop will be black. Then finally we will release our video. Then we are going to destroy all the window. Release and cv2 dot destroy all windows. This one. Okay, so Control B for running this. So it will open my initial webcam. So you can see here it is my initial webcam. So now we are trying to actually implement the logic of the Harry Potter invisible clock. So the logic behind this Harry Potter invisible clock is, first we are capturing our initial frame, so without any person, without anything. So that means first we have to capture the image of the initial frame. After capturing the initial frame, we are creating the marks. So after creating the marks, we are joining these marks using the red color, because I am using the cloth, red cloth. You can use blue, white, not white actually, blue, green, whatever you can. Okay, so in this tutorial I am using my red cloth. Okay, so what you need to do, first we have to capture the background, so without me. Okay, then after coming with me with cloth, so we have to detect the color of the cloth. Then we are making it invisible. So first what we need to do, first we need to capture the background without me. Okay, so let's create this one. So what we need to do, first we have to import the numpy, because in Opencv when this frame will open, so it will be flipping. So now we have to flip our background. Okay, and we also capture this background in a specific time. So let's initialize our background as 0, background as 0, and we are creating a loop to what do you call, capture the background image. So let's say red, and the background equal, let's say video dot read. So we are reading this video frame, and now we have to flip this one. Okay, so np has a function called np dot flip Okay, it will help us to flip the what do you call, flip the background. So in this the parameter we have to put here the background, background background and axis equal 1. So make sure that your spelling should be correct, background, background. Okay, so now we are trying to display it here. Okay, here it is. Okay, cb2.im show. Okay, function. So in the name, let's say background, background. Okay, and the material should be the background. So background. Okay, so let's run for Control V. I think I'm okay. Mistake. Okay, so it will open my webcam right now. So you can see here it is the actual display. Okay, it's real time and it will capture my display. So in this case I am here. Okay, but we are capturing this image without me. So after capturing this without me, I am coming here. Okay, so it will try to find the red color. After finding the red color, it will be make some marks. Okay, so now what we need to do, we also need to flip our images. So that's why np dot flip, then we have to put here image, the axis should be 1. Okay, then what we need to do, we need to convert our frame in a ssb format color. So because we are detecting the color, so that's why you have to change our background in the ssb format color, cb2.cbt color. So the source, so what actually the source should be the image and the code. So cb2 have some built-in color code, so we are easily convert this into a visual to a ssb format. So here is ssb. Okay, so after formatting, converting this frame into a ssb format, we are doing some image pre-processing. So let's blur it right now. Blur equal, let's say cb2 dot Gaussian blur. You can also use the simple blur. So first one is the source and second one is the kernel size, and the this is the sigma x value. So source should be the ssb format color, and the kernel size, let's say 35 by 35, or you can put here 55, 10, 10, whatever you can. Okay, I put here 35 here, and the sigma x value, let's put here initially as 0. Okay, so now what we need to do, we need to define the lower range of the red color detection. So let's define the lower, let's say lower of the red color. So let's say np dot array. Then what you need to do, we need to put here some values. So you can also use the trackbar to find these types of value, because I already implement it in previously. Okay, and I got these values. So let's say upper equal np dot array. Okay, array. So let's say, okay, so 10 and the 255 and the 255. So it is the defining the lower range of the color detection. So okay, we are defining this lower value of this red color. So now we are using this marks. Okay, so cb2 dot in range. Okay, in range, in range. So source and the lower bound value and the upper bound value. So source should be at the ssb format color, and the lower bound should be what you call, lower bound is the lower, lower, and the upper should be upper. Okay, so if I trying to print this one, control D. Okay, so this one also our marks 1, marks 01. Okay, and this one should be marks 01. Control B. So it will run and take some time to running this. Okay, actually I am using my CPU, not GPU here. Okay, so take some time, it will loading. Okay, I think some mistake. Okay, let's press Q. Okay, no, let's run again. I think my computer is so slow. Okay, to load this type. Okay, so it is the marks. Okay, you can see here it is the marks, and it's the background, it's the marks, it's the real background. Okay, so it's the actual marks. Okay, so now what we need to do, we need to do something else. Okay, it is a marks. So to delete the red color, I think my face is should be red of the what do you call, my lights should be red. Okay, so that's why. So let's press Q, and also we need to initialize the lower right below, also the range of this. So let's say lower, let's say right below, np dot array. Okay, so let's remove it, and let's put here the value of 170 and 120 and 70. So you can see here this value is just changing right now. Okay, so all the value as it is. Okay, so let's copy out from here. Also we control C, control B, and let's say upper red, and let's change it as 100. Okay, then create the another marks of it. So marks 02 equal is already same. Okay, control C, control B. So this one be lower red, and this one the upper red. Okay, so our work is done right now. So what we need to do, so we need to add those marks. So marks 01 plus marks 02. Okay, so we are adding those marks, and we will do some pre-processing steps, like you can do dilation, erosion. Okay, so many things. But CB2 have a built-in library called the morphological EX, so it will help us to do some image pre-processing. That means remove the noise from the picture. Okay, so we are using the morphological EX, but you can do some blurring effect, some erosion, some dilation, some edge detection also be. But morphological will help us to do all the things in a one way. So now what you need to do, so let's say marks equal, so marks equal cb2 dot morphologically. My thing, my computer is so slow, it takes some time. Okay, what happening? Okay, so marks equal so now we are adding this marks. So now we have to do the morphological operation. So morphological operation, make sure that method name should be okay. So first one is the source and the op and the kernel size. So first you have to put here the marks and the op should be the cp2 dot marks op. I think marks op marks not actually more. Oh, what we should morph morph morph, yes, morph open, yeah, this one. So now we have to initialize the kernel. So we are using this numpy1 kernel because we are also already convert our image into a binary image. So that's why you have to put here the binary image kernel. So np dot ones. So after this kernel, let's do 5,5. Okay, this one. Okay, then what we need to do, we need to initialize this. Let's remove it. Okay, np dot uint8. Okay, so now this will be correct right now. First one and second one now done. Okay, so now we are going to convert our frame into a background frame. That's mean our red clock should be invisible. So that's why we have to put your image, and now np dot higher. So inside this higher function, we have to put here the marks equal 255. So now it's the trick actually. It's the actual trick. Okay. So if their marks should be 255 in the image, So we are flipping, that's not a flipping actually, we are converting this image into a in the background, okay, into the background, okay. So np dot here, so max equal 255. Okay, this should be equal. Actually I am suffering from fever, okay. So now what you need to do, we just now we are ready all these things. So let's hide the panel now. Okay, so it is the whole code. So first we are initialize the cbt module, then we are initialize the numpy array. So now we are trying to capture the video capture frame using this video capture class. Then we are capturing our background. Then after capturing our background, we are flipping this background. So flipping the background, then we are reading this frame by in a infinite loop. Then we also flip our real frame within which one is real time. Then we are converting our frame into SSB color format. So if we are finding the red color, so that's why you have to convert our colors in a SSB format. So then we are applying some image processing called blur. Then we are defining the lower bound and the upper bound of the red color and creating the marks. After creating the marks, we are joining the marks, and we will do some image pre-processing steps like dilation, erosion. That's it. So it also happen in the morphological ex. So that's we put here all the things here. And finally, if we are getting the marks f2355, so we are converting this one is a what do you call, we are converting this one is a background color, okay. So that's means it looks like the invisible, okay. So it is the final. So let's run it and let's open my lights, okay. So now let's control B. It will take some time to load this. Okay, you can see here it's my display. So this one, so it is my face when I am trying to wire the red clock. So you can see here it will be invisible, okay. So this one, I think it should be not right now, okay, not invisible. So I think some problem. So now we have to check it, or is the problem. Oh, so we need to capture the frame. It's a time. So we are capturing this frame after the dragon, okay. So that should be right. Second should be 3. Then all is done. Now, okay. So let's run it for Control B again. And see what happened actually. I don't know it is working right now or not. Okay, yep, it is working actually. And so some problem right now. I don't know why. So let's remove it and take some time. Wow, yep, it is doing right now. Okay, so let's see what actually happened here. Inside my code, I think color should be same 255. Okay, this color is not good actually, it's 180. So let's run again for Control B and check it again. Okay, so check it right now. Invisible clock. Okay, it's right now. Fine. Okay. So you can see here it will be invisible right now. Actually, the color format should be the right, and also my camera is not so good. I captured this video actually from my out of my home. So now it's night now, so I am capturing this video right now. So you can see it will be invisible my clock. So you can see here it will be invisible. So as your camera is more clear, so it will give you the correct output or the correct result. So in my case, I think my color code should be some mismatch. So this one the tutorial. Hope guys you will enjoy this video, and make sure to subscribe my channel, and don't forget to hit the bell icon for never missing update.